2 whole years ago.
Algebra 1, Algebra 2.
So if you see, excuse me, if you see f of 1, that means the function. See, this is f of x over here. That means the function when x is 1. So that all it means is plug in 1 for x. That's all it means. So we're going to take that function f of x and we're going to make it f of 1. So wherever you see an x, plug in 1. Now, f of 1 is the directions, so I don't do anything with f of 1. F of 1, by the way, f of x, that's the same thing as y equals x squared minus 2x. So we're saying plug in 1 for x, and what does y equal? That's what we're asking. So what does y equal, or f of 1? 1 squared is 1, minus 2 times 1 is 2, so f of 1 equals negative 1. So if I see f of negative 3, that's the same thing as what does y equal when x is negative 3. That's what that means. So we take f of negative 3, and in this equation, wherever we see an x, make it a parenthesis negative 3. So negative 3 squared minus 2 times negative 3. What happens when we take negative 3 squared? Negative 3 times negative 3 is 9. And then here we're minusing a 2 but multiplying by a negative number, so that's going to cancel out the negatives and become positive 6. So f of negative 3 is 15. And then our third example, f of 0. So if we put in f of 0 into the equation, wherever you see an x, replace that with 0. So we'll have 0 squared minus 2 times 0. So what's f of 0 equal? 0. So if you see f of a number, it's just telling you replace x with that number. And that's what we're going to do a bunch of that today. This core concept right here is what we've already talked about. A lot of the stuff we're doing today, we've talked about the past few days, so some of it's going to review. So this is talking about horizontal translations. Remember, if it's a horizontal, it's going to be inside of the parenthesis. Remember, if it's horizontal, it's going to be inside of parenthesis. And if it's horizontal and it's inside of parenthesis, it's also like opposite of what you think. And then vertical transformation or translations, vertical translations, we have adding or subtracting outside of the function. It's outside of a parenthesis. And that one is just the sign that it is. We've already talked about that, right? Here it is again. This is on the next page. This is how I showed it to you the other day in the notes. The exact same thing. Probably just copied and pasted it. Vertical translation, if I have a plus k, that's vertically, where am I going to go? Plus k is where? Plus is where? Up, thank you. And minus k is down. And then for horizontal translations, you see we have parentheses. If it is a minus h, it is to the right, because it's always opposite if it's horizontal. Always opposite if it's horizontal. If it's in the parentheses, it's always opposite. And then what about x plus h? Where's that going to go? Left. All right. So we're going to write translations of functions. Let f of x equals absolute value x. Write a function g whose graph is a translation 4 units up of the graph of f. So we are going to write a function g. First thing I want you to notice, what's the name of the function? G. So we're going to start by writing g of x. That's the name of our function g of x. You see the original one's f of x. Okay. Says whose graph is a translation 4 units up of the graph of f. So what I'm going to say is g of x is equal to that graph of f of x, but add 4 up. So if it's adding 4 up, that goes on the outside of the f of x. It goes on the outside of those parentheses. All right, that's just using the formula. And then from there, I'm going to use some substitution. What is f of x? What is f of x? What is the function of x? I'm pointing to it. Absolute value of x. That's what f of x is. So I'm just going to replace it. So g of x is equal to your absolute value of x plus 4. And that's the answer. So we started absolute value of x, and then we just moved it up 4. The plus 4 goes on the outside. And I'm going through this long process of substituting, just so you've had exposure to it, and then it might get more complicated later. You might need to look at this right later. Okay, B, write a function h whose graph is a translation 8 units down of the graph of f. So what's the name of the function? Okay, let's try this as a class. What's the name of the function? H. Okay, h of x. H of x is equal to the function f of x, but then it's a translation 8 units down. So down is outside of f of x, minus 8. And then we go back and say, what is our f of x function? What is f of x equal to? What is f of x? What's the function? Absolute value of x minus 8. So you're just replacing f of x with absolute value of x. That's all. So that is the function. Next, write a function m whose graph is a translation 5 units to the right of f. What's the name of the function? M of x. M of x. M of x is equal to the f of x, but we have to do 5 units right. So this is right. That is a horizontal. Where's it go if it's right or horizontal? Where's it go? In the parentheses, right? Inside the parentheses it was horizontal. So I'm going to write this as f of, and then x, and then if it's 5 units right, which sign am I going to use for right? Minus 5. Okay, and then mine's not at the top of the paper. Yours is at the top of the paper. It says f of x equals absolute value of x, right? It was at the top of the paper. I just had to rewrite it because mine's not there. When we are doing f of, and there's a different thing in the parenthesis, that means you take this function and wherever you see an x, you replace it with x minus 5. So wherever we see an x, make it x minus 5. So our m of x function is, wherever I see an x, absolute value of x minus 5. Okay. And then question D, write a function p whose graph is a translation 6 units left of the graph of f. So what's the name of my function? Let me try this as a class. What's the name of my function? Like 6 of you. P of x equal to, and then this is going to be a translation 6 units to the left. So when it's to the left, does that go inside or outside? Okay. Inside. If it's inside, it's going to be opposite. So if we went left, then we're actually going to add 6. And then when I have f of something, that means replace the x with that thing. Replace the x with that thing. So in this equation, instead of absolute value of x, I'm going to have absolute value of that thing. P of x equals absolute value x plus 6. All right. Now we're going to make it a little bit more complicated. Example 2, f of x is now 2x plus 1. So f of x is not a parent function anymore, it's just a function. It's not a parent function anymore, it's just a function. And we're going to write a function g whose graph is a translation 3 units down of the graph of f. We're going to write a function g whose graph is a translation 3 units down. So we're going to do this graphically and algebraically. Let's start with graphically. We went over how to graph lines like the first day of class. Let's go over it again. Let's graph this function. How do we graph? Remember, f of x is the same thing as y equals. How do we graph 2x plus 1? We graph 2x plus 1. Do the whole worksheet up. Guys, call people. You guys are going to call too. Natalie?
First, you go up on the one on the y-axis.
Okay, so we're going to find our y-intercept, which is at 0, 1. Excellent. And Aiden, you know what to do next?
We need to go up 2 over 1.
What's that?
Continue doing that.
What's that?
The slope.
Slope. So we're going to go up 2 over 1, or we can go down 2 left. And then that's the original function, so we're going to just dash it. And it says to take function f and translate it 3 units down. So graphically, if I go to every dot that I just drew and go 1, 2, 3 units down and draw a new dot, I will have my new graph. We just went 3 units down. That is graphically. Are you following me graphically? 3 units down. Algebraically. By the way, before I do it algebraically, what is the slope of this blue line? What is the slope of this new line? What's the slope? Okay. Yeah, it's the exact same. They're parallel lines, okay? So same slope, 2, and then what is the y-intercept of this new line? Shay, what's the y-intercept? Where's it across the y-axis? -2, right. So if I wanted to write the equation, that would be like y equals 2x minus 2. That's graphically. We're going to do it algebraically and get the same answer. Okay. So how do we do it algebraically? Write the function g. What's the name of the function? G of x. And so we're going to take the original function, and we are going to do what to that original function? Subtract 3. Now I'm going to do some replacing here. Wherever I see f of x, I'm going to write 2x plus 1. Like these are equal to each other. So I'm going to have g of x is equal to my function 2x plus 1. And then subtract 3. So I replaced f of x with 2x plus 1. And I did those parentheses because sometimes they're really helpful. They don't really do anything from here. They don't hurt us or anything, but sometimes they're really important. You'll see. Now, can I simplify anything? Are there any like terms I could combine? Anything I could multiply? Is there anything I could do to simplify this? Yes, I could add together the plus 1 and the minus 3. So I have g of x equals 2x minus 2. And is that the same thing we got graphically? 2x minus 2. You do not have to do this both graphically and algebraically, but I'm giving you options. So let's do the next example. F of x equals 2x plus 1, that's the same function that we just did. So we'll just quickly sketch that one. It begins at 0, 1, and then up to over 1. And this one is a translation 2 units to the left. So every dot that you graphed, if you just take them and go 2 units left, you should have your new line. Just go 2 units left. Okay, then we're gonna do this algebraically next. And we're gonna get the exact same answer that we got graphically. We're gonna do it algebraically. So what is the name of my new function?
H of x.
H of x. They tell you in the directions, H of x equals. Now this is 2 to the left. So if it's to the left, is that inside or outside parentheses? Inside. So we're going to do f of parenthesis x, and then when it goes to the left, we actually write plus 2. Because it's in the parentheses, it's always going to be opposite. And then when I have f of something, that means replace x with that. Replace x with that. So my next step looks like h of x is equal to, I'm going to take this function, and I'm going to take out x and put in x plus 2. So I'll have 2 parenthesis x plus 2 plus 1. So wherever there was an x, I replaced it with x plus 2. And then you say, can you simplify that at all? Can I make it simpler? Carly, what could we do?
Multiply the x and the 2 by 2.
Oh, this 2 and that? Okay, gotcha. Yeah, we're going to distribute into the parentheses. Aren't I such a good student? 2x plus 4 plus 1. And then from there, is there anything else that we could simplify? Yes, David?
Add 4 plus 1.
Yeah, 2x plus 5. And if we look at the graph, does our graph cross the y-axis at 5? Yes. So we know we did it right. Graphically and algebraically. All right. Moving along. So much fun. The next, next one, the concept is just a reminder of our reflections, which we've been doing for a couple days. Remember, if it is a reflection in the x-axis, reflection in the x-axis is going up and down. That's the vertical reflection. And if it's vertical, it's outside of the parenthesis. If it's a reflection in the y-axis, that's going left to right, that's horizontal. That is inside of the parenthesis. So we have those two situations right here, where we've got inside and outside the parenthesis. Here we have a function. F of x is absolute value of x plus 3 plus 1. Let's graph that. What's absolute value look like? What's absolute value look like? You just yell it out. It's a B! It's a B, right. Absolute value is a B. And then normally it's centered at 0, 0. But this one has a plus 3 and a plus 1. That's going to translate. What's the plus 3 going to do? Translate which way? To left 3, and then what's the plus 1 do? Oops, up 1. So we're going to take that B that's normally at 0, 0, and we're going to go left 3, up 1, and then we're just going to draw our B there. And make that one dashed. And then this says we have to write a function whose graph is a reflection in the x-axis of the graph of f. It's going to reflect in the x-axis. So in the x-axis means it's going to go flip over the x-axis. So which way are we going, vertically or horizontally? It's in the x-axis. Which way is that? Vertically. So that means when we do, what's the name of my function? G of x. When we do g of x, that's going to be negative outside of the function, outside of the parentheses. Now here's where you really have to be careful. So we're going to do negative the whole function, the entire function, negative the entire function. What's the entire function? So we're going to do negative the whole function, absolute value x plus 3 plus 1. We're going to do negative parenthesis the entire function. That parenthesis is important. So the negative sign is outside of the parenthesis, though. The negative sign is outside of the parenthesis. So why is that parenthesis so important? Because when we go and we make everything negative, you have to make the absolute value negative, and you have to make the 1 negative. You have to make everything negative. And by the way, those absolute value walls, you cannot cross them. They are walls you cannot cross. So that negative sign stays outside. It does not go inside. It stays outside. So we will have g of x equals negative absolute value x plus 3, and then minus 1. It changes that sign of the 1 at the end. If you don't pay attention to detail, you probably miss that a lot. So make sure when we are doing negative the function, it's the whole function. And graphically, by the way, this flips over the x-axis. So since it's currently 1 up from the x-axis, it'll be 1 down from the x-axis. This is where it would be located. That's what it would look like. So where the original function has a plus 1 at the end of it, this one has a minus 1 because it's 1 down. Okay, if you don't get the graphs totally done, I want to make sure we get through the algebraic part, so I'm not as worried about the graphs. I will post the notes up on Canvas too if you need it. All right, reflection, write a function h whose graph is a reflection in the y-axis of the graph. So this is the exact same function as before. The name of the function is h, and we are reflecting in the y-axis of the graph. So if it's reflecting in the y-axis, that is what kind of reflection? It's horizontal, so it's going to go inside of the parentheses. We're going to do f of negative x. And when it's inside of the parentheses, that's when we are replacing x with whatever is in here. We're going to replace x with negative x. We're going to replace x with negative x. So I will have h of x equals, in my function, absolute value. Instead of x, I now have negative x plus 3. So instead of x, I have negative x. Okay, there's 4 of them at the bottom that say student practice. I'll give you about 1 minute to try any or all of those. Near all of those, we'll go over it. What's the name of the function? G of x. Okay, just with time, I'm gonna start going over them. I know not everybody tried every single one yet. So we're just gonna go over them with time, and then after I go over them, I want you to grab your computer and log in, just to see that it was working last period, just to see that it's working again. F of x equals 3x, we're gonna do a translation 5 units up. That one's gonna be g of x equals the 3x, and then add 5 onto that. F of x equals absolute value of x minus 3, translation 4 units to the right. So if it's to the right, that one's going to be in parentheses. That one's going to be like f of x, and then we're going to do minus 4. So wherever you see an x, you replace that with x minus 4. G of x equals absolute value of x minus 4 minus 3. So we're taking the function and just subtracting the 4 from the x. Number 3, there's a reflection in the x-axis. So we'll have g of x, and we're going to take the entire function and make it negative. So we'll have negative absolute value x plus 2 minus 1, and then we negative that whole function. So when you negative that whole function, it distributes, and it changes all the signs. Absolute value of x plus 2 plus 1. So it's absolute value x plus 2 and then plus 1. And then the last one, it's a reflection in the y-axis, so that's where we're going to do f of negative x. Wherever you see an x, change it into a parenthesis negative x. So g of x equals 1/2 negative x plus 1, and then simplify it. G of x equals negative 1/2 x plus 1. So the assignment is on the computer, but I do have a backup plan if we have any issues. I want you to usually like 6 minutes, grab the computer, see that you can log on to Big Ideas. Grab your computer, see if we can log on to Big Ideas. If you want to grab the computer next to you, somebody next to you probably would need it. If you want to grab 2 of them while you're up there, the person next to you could use it. Want to help out? So try to log on to one login and get to Big Ideas. It was working last period, so fingers crossed. Remember, you have to put at Lakota students after your ID name. Log out. So go to lakota.onelogin.com, and you have to log in with your ID at lakotastudents.com. Put in your user ID so that you can get on it. And when you do log in, make sure it's you in the top corner, because people don't log out and then. Did it work? Well, if it works, that is great, but I would have that work. Okay, so on the or if you're having trouble at home getting on. Somebody talk.
I'll be.
Hey guys, I got 3 minutes and I want to make sure everybody knows this. And for some reason, it's not working. If you have trouble at home, I posted on Canvas the book, and these are the numbers, and I also wrote this on Canvas. If you know you can't, if you know you don't have a computer at home to use, print it out. So if you don't have a computer at home, please come get a copy before you leave and write down those numbers. Oh, sorry. Whatever is going on. If you don't have a computer or you know your internet's spotty or something, I don't want you to come in and give me excuses tomorrow. Also, if you have trouble, 4th period study hall, you could come in and use the computer if you're having issues tonight. But the assignment is on Big Ideas. I have backup plan on Canvas or right here in my hand. You need to write down those numbers. Anybody else need a backup plan?
Please excuse the interruption. It's time for afternoon announcements. Students, bring back your EMS tomorrow and give them to your third bell teacher. There is a student government meeting today after school at community room. Tonight is open house. Students, don't forget to give your parents your schedule so they can walk your classes. 0 period starts at 6:15. First period starts at 6:30. We will have clubs and organizations here at 6 o'clock if they want to introduce themselves to PTSO or athletic boosters or the like. Once again, don't forget to have your parents bring your schedule to after school night tonight. The doors will open at 6 o'clock. This concludes the announcements for the day. Make it a great afternoon. Please drive safely in the parking lot, but most especially on your way home.
So if you get on Canvas and Big Ideas is not
And as
working,
always, go Fibers.
I should have known. If you get on Canvas, if Big Ideas is not working, you get on Canvas, there's the book, and then those are the numbers. But if you don't have internet at all, you won't be able to do any of it. So have a great day. See you tomorrow. Maybe see some of your parents tonight. Oh. All they do is say hi. I just don't really care. Good job. We'll see. What's up, dude? How are ya? Good. Good. I'm here. Allie. You like how I threw down today with the girls? I really wanted to do it. All I wanted to do is